In this lesson, we're going to be looking at how to graph sine and cosine. So let's take a look at the coordinate plane that we've been dealing with thus far. Here we've got our radian measures, 0, pi over 2, pi, 3 pi over 2. And what we've learned is when you take the sine of 0, you end up getting 0, which we've got right over here. So let's continue on. If we get the sine pi over 2, remember that was equal to 1. And if we keep going, we get sine of pi, 0, sine of 3 pi over 2, negative 1, back to sine of 2 pi, let's keep going around, that's 0, 1, 0, negative 1, 0, 1, 0, negative 1, 0, 15, just kidding, 1, 0, negative 1, and it keeps going back and forth, right? And you just see that we're oscillating between these values, 0, 1, 0, and negative 1. So when we graph that, you're going to see just what that ends up looking like. Sine, make 'em wonder what you got. All right, so here we got our basic parent graphs of sine x and cosine x. The first thing I want you to notice is that our x-axis is in radian measure, right? See, we've got 0, pi over 2, pi, 3 pi over 2. So our x-axis is going to be in radians. Same thing on the negative x-axis. So let's take a look at sine first. Here we had sine of 0, which we talked about was 0. Sine of pi over 2 was 1. Sine of pi was 0. Sine of 3 pi over 2 was negative 1. And then sine of 2 pi back to 0. And what you see is this oscillation between those numbers. Cosine, on the other hand, when we take the cosine of 0, we get 1. Cosine pi over 2 is 0. Cosine pi is negative 1. Then cosine 3 pi over 2 is back to 0. So we have this same oscillation, except it's just shifted a little bit. At 0, we're starting high, whereas sine, at 0, we're starting at 0. You may have seen these similar graphs when looking at sound waves or things like that. Okay, so there's some key vocabulary you're going to want to know when dealing with these graphs. First of all is amplitude. Let's think of amplitude as the height of your graph. So if we've got this graph down here, we can see that it goes all the way up at its highest peak is at 2. And then if we continue on, the lowest peak down here is negative 2. So the amplitude of this graph would be 2. Let's try drawing a graph, the same graph with an amplitude of 3. In this case, it would take the same pattern but go all the way up to 3, all the way down to negative 3. Up to 3, down to negative 3. Let's do a graph with an amplitude of 1. That would do the same pattern, up to 1, down to negative 1, up to 1, down to negative 1. So amplitude is just the height of your graph. Next up is the period, and we can think of the period as the distance for one oscillation or a cycle, one cycle of the graph. So for this graph down here, we see we start at 0, we go up, down, back to 0. So this period is 2 pi. If we had a period of, let's say, pi, we'd need to complete that same cycle in this distance only up to pi. Let's say we had a period of 4 pi. That would be our distance of up, down, 4 pi. So again, the period is just the distance for one complete oscillation of the graph. Something very similar to the period is the frequency, and this is just another way to write it, and the frequency is always just 1 divided by the period. This is just saying one cycle occurs for each period. So for this graph, you'd have one complete cycle every 2 pi radians. Lastly, let's take a look at our phase shift and vertical translation. A phase shift is just a horizontal shift of the graph. So let's say we took this graph of cosine and shifted it over pi over 2. It would be the same exact graph except shifted pi over 2 to the right. A vertical translation is a vertical shift in the graph. So let's say we shifted this graph up 1. Now it's going to be the same exact graph, except every point is shifted up 1 on the y-axis. So these shifts aren't too difficult. You just need to move your graph left, right, and up or down.